Hello, everybody. Cool. Can I get started?
Yes, let's do it.
All right. Hello, everybody. Really excited to be presenting at ETHMiami. I'll be doing so basically what I'll be doing is telling you a little bit about what the graph is and why do we need the graph if you're creating a DApp, a decentralized application. What is indexing? Why do you need indexing in decentralized application? How does the graph do it? What is a subgraph? And at the end, we'll be coding a subgraph end to end from beginning till the end. If you have any questions, I would really love to take it in between. So if you have a question, just post them in your chat box right here, and I'll take them up in, let's say, 30 minutes or 40 minutes, whenever I find some time. But if you have a laptop around with you, I would suggest you guys to just have it, because this is going to be a live coding session in which what I think is, if you are along with me, you will be able to code at the end of the particular session. So without further ado, because we have a lot to cover, let's get started. I'm really excited to be presenting in front of you guys. Cool. So all right, let's do it. So while we're talking about indexing smart contracts using the graph, right? But we need to first understand, why do we need to use the graph? Like, why do we need to use it? So basically, what is a DApp? A DApp is a decentralized application. Everybody knows that. But in reality, the main crux or the main reason why we call a DApp or decentralized application, or the reason why we produce it, is not just to use the Ethereum blockchain's interoperability, but also not to have any single points of failures. Because we are working with distributed peer-to-peer ecosystems, we always and always would need applications. We would always and always need applications which actually have no single point of failures. And also because they are peer-to-peer decentralized distributed applications, they have a bigger load on indexing servers. So if you are creating something on a centralized basis, there is a good chance that it will be broken. And that's why we need to index the whole ecosystem, or the whole DApp that you're having, and produce the front-end information via the APIs, using an indexing protocol which is as decentralized as the blockchain that you're using to actually make it happen. And it's a very famous saying that your DApp is as strong as its weakest link, right? And if you have created a centralized party in between, then you can expect to have failures in between. And that's why we have to use the graph. Why specifically do we need to create the graph protocol and not create your own centralized servers? Then the simple answer is that these are the number of blocks that you will be indexing, or these are the number of blocks you will be scanning on Ethereum if you want your particular information. Let's say you want the information of CryptoKitties that was actually published as a game in 2017, and you want a specific information related to CryptoKitties, one particular feature, let's say when it was owned by one person and when was the genesis of the same, right? So how do you do that? You would have to scan all the blocks from the beginning till these 15 million blocks. Inside every block, this will be the kind of information that you will be catering to. This kind of information, which is not the most coolest. It's too much of information in every block. It's not like one block is dedicated to, let's say, Uniswap transaction, the second block is dedicated to some other transaction, and the third block is dedicated to CryptoKitties transaction, and you'll actually index the third block. Every block has Uniswap information, CryptoKitties information, BAYC information, and you have to filter your information out of it. So let's say you want to create an application which has the information which is catering to all things in that involves CryptoKitties. You'll have to index the Ethereum blockchain since 2017, which is at least 13 or 12 million blocks. And in every block, you will have to scan and find out what information do you need for yourself. This is something which is, I think, not practically possible for a centralized server. If it is possible not at scale. It will eventually fail, your servers will run down, and you will be overburdened with the GCP costs that are coming around. You have to use a decentralized protocol to index a decentralized blockchain, not just for the sake of decentralization and single point of failure issues, but also to have an uptime and economic reasons to have a front end which is able to serve the same. Right. And so basically what the graph does is it indexes all the information that you need for your particular smart contracts and put it out to you in form of GraphQL APIs. If you see in this particular great GIF that was first presented by Brian, one of my cool co-workers, he said that this is the information inside the blockchain, right? And you need your green information, which is the BAYC smart contract information, and all the interactions that user have done in that particular. How do you do that? The way to do it is that these particular things which are arranged strategically, which is the graph, and create a subgraph for your particular smart contract, so that you just need the green information for your information basis, right? So what is the graph? The graph, so this is like, the architecture that you would have to use if you don't have the graph. You have this blockchain, you have this user interface that you need to portray your information to. How do you do that? Your user is interacting with the blockchain via the smart contract. From the blockchain, how do you get that information to the user? The only way is that you either you scan every block, which is very architecturally heavy and code wise very shitty looking. This is a code that a junior first intern developer would be looking forward to having. On the other hand, sorry, if you use the graph, this is how it will look like. This is how the things will be looking like. An indexing protocol in between. So the user interacts with the blockchain via the smart contract, right? Puts everything over there. And from the blockchain to the user, the dApp front end, you have an indexing protocol like the graph, which will be indexing all your information. All you have to do is query the APIs so that you can get your results, right? At the end, you will be creating a subgraph, which will have GraphQL front ends, which will actually portray everything via GraphQL APIs to the users. All right. So this is how beautifully your code will be looking like at the end of creating a subgraph for your particular APIs. Right. So this is about the graph. The graph, if you want the theoretical information or theoretical definition, it is an indexing protocol. What is indexing? You can also say what the graph, what Google does for Web 2 is what the graph does for Web 3. Basically, Google indexes all the information that resides on the web, right? And when you do a Google search, you get your results in 0.00008 seconds. Why? Because there is pre-computed computation that's been done by the Google to scrape all the web and give you the best information that's needed. Similarly, the graph indexes and pre-computes all the information that you need via subgraphs, right? So all the information from the that exists on the blockchain, but you need it in 1 second. So the graph is an indexing protocol which indexes and pre-computes everything via the subgraphs that you create, and you get your front results by querying a GraphQL API in 0.01 seconds. So this is how the graph actually functions. So what's the use of a graph, or what's the use of a subgraph, and where do you have to use it in your architecture while thinking of creating a dApp? Is basically you'll write a smart contract for your user to interact with the smart contract, right? There'll be a UI that you'll have, and there'll be a subgraph in between, so that whenever your user interacts with the blockchain, that information will be going directly inside the smart contract. But when that smart contract has to be portrayed to the user, you need the information to be portrayed to the user. You would have a line or the middleware, which is subgraph, so that all the pre-computation is done by the blockchain, and all you need is all you need is just the information that is being queried via the GraphQL APIs. Right? What are some specific examples? It's best to learn from live examples who are actually using the graph, right? So basically, if I go on info.uniswap page, right? And if I need all the information that exists on Uniswap up till now from the first day I traded, that's so tough, right? And what the Uniswap team has done is that whatever user does, if I go on app.uniswap and I do a trade, directly that user is interacting with the smart contract. right? That's one part of the picture. The second part is when the interaction is done and the blockchain stores that information, how do you portray that blockchain information to the front end? That's via the middle layer or the architecture I was talking about, which is the graph. If you see here, I talked about the user interacts with the Uniswap smart contracts directly. And how does the smart contract portray the information that the user has interacted with it? That is why the subgraph to your particular front end. This is how the UI looks like, and it is at the back end using the graph. Let's find out how. If I go on, see, if you go over here, you will be able to see api.thegraph.com/uniswap units, right? So all the information you are seeing over here coming around is by querying the subgraph that's created by Uniswap and the API that's been generated by the subgraph. If you want to see, let's go on the graph.com/hosted service, and I'll go to the Unis. This is one of the examples, right? The Uniswap subgraph, right? If you see over here. So the Uniswap team has deployed their subgraph, and at the end, they get this api.thegraph.com/subgraph, that this particular API link. Using this, they are able to query the subgraph and
one
able
second.
to.
People asking if they can see your screen. Can you see the messages in the chat and address them, please?
Can you see my screen?
Yeah, I can see your screen, but if you can just check the chat messages and see if anyone has any other questions. Okay, they can see now. Okay,
up.
all right. They said they can see now.
Oh, okay, that's weird. Okay, no worries. Now we can, I hope. So this is the Uniswap page, right? And I was telling you that this is the network and they are using the graph. And if here I go, Uniswap, I'll be able to see that they are using the graph and they are querying the GraphQL. So they create a subgraph, and that subgraph gives a API key API at the end, which is a GraphQL API, and they just query it to get this front end information, right? So when a dApp is created, there is a smart contract. So basically, user interacts with the smart contracts and does all its functions. How does that smart contract information is portrayed to the user back in their dApp information? That's via the graph. So you create a subgraph for your smart contract, and using that subgraph, you get an API at the end, like you can see over here. And querying that API, you get the front end information that, you can see over here. So what is a subgraph? You can say the graph indexes all the information that you need. It is an event-based indexing information structure. But how do you tell the graph that this is my smart contract and these are the events that I'm looking forward to index, and this is what I need at the end? That's not possible. And that's where you have to create a subgraph. That's where you have to code a subgraph, right? You can say the graph indexes all the information. What you need is what you have to code. So let's say I need the information of the Bored Ape Yacht Club NFTs, right? So I will go on BAYC smart contract and create my subgraph so that at the end, I only get the BAYC information. I don't need all the blockchain information that the graph is actually indexing for me. All I need is my particular smart contract being indexed. So every activity is being traced by the graph, and I'm able to get all the information for myself via creating a subgraph. So subgraph is telling the graph that this is the smart contract and these are the events I'm actually interested in. Just index these for me, and that's what it is done. And at the end, you get an API querying that. You are able to tell your front end what you need and what you not. Where do you deploy a subgraph? There are two places where you deploy a subgraph. First place is a hosted service, and the second one is the graph network. The hosted service is the one which we are actually deprecating in some amount of time, and eventually moving to the graph network. The difference between the hosted service and the graph network is the hosted service is a SaaS product, which is centralized indexer that was just being run by one particular core dev. while the graph network is a decentralized indexing solution. As I was telling you, we need no single point of failure, right? So the graph network is a decentralized indexing solution which does the same thing. If you think about the subgraph code, everything remains the same, just that the indexing is not done by one person but 100 plus people of consortium of 100 plus people. And that's how you get your information from 100 plus sources of data, so you know it is right or wrong, right? So the hosted service is a SaaS product. The graph network is the one we actually aspire to have, and is the decentralized version of the same. What is inside a subgraph, right? After this, we'll be jumping into coding a subgraph. So I would suggest you guys, everybody, to know what is a subgraph, because when we dive in, I would assume that you all know what is the structure of a subgraph. Like you create npm init and you get a package.json which has all the dependencies, then you deploy a few things and stuff like that. It is similar. Similarly, we'll be doing graph init. We'll be getting a few dependencies that will be a part of package.json. The second thing is you have to tell what you would want, right? All the events, which particular smart contract that you are indexing, and so on and so forth. So for that, you would need the YAML file or the manifest file. This is the introduction of your subgraph, that this is what I need as events to be indexed. This is the smart contract address that I want to be indexing, so on and so forth. The third thing is, if you want to query something, you have to define schema. Even if you are wanting to query a MongoDB, SQL database, you have to create a schema for the same. Similarly, if you want to have a GraphQL information being queried via schema basis, you have to have a schema file in which you define that these are the particular entities that I want to query. So in schema file, you define the entities that you would want to query. And the third one is mapping.ts file. This is the main logic file. So what the graph does is it gives you all the raw data from the events. It sees the manifest file. It sees that, okay, this is the event I want to track. It gives you all the raw data. How do you convert that raw data into the schema that you have defined? That is via the mapping.ts file. All right. So mapping.ts file actually converts all the raw data that you get from the graph node to your schema information, that so that you can query it in the most perfect manner. It is in a way a computational file source that you create, right? The generated folder is the one which is the most important one, and is the beauty of the graph, in which your TypeScript is converted so that you can create the mapping.ts file. This is something you would learn while you code. So don't worry about it. I hope nobody has any problems up till here. We'll be doing a live code right after it. So if anybody has any questions up till now, please push them to through your chat box right now. If you don't have a question, then I would suggest you two things. The first one is open your laptop, be very excited. You'll be coding your first subgraph. Or the second one, it is not going to be very complicated, but you would, I promise you, you would learn the basics of writing subgraphs after this. So that's the first thing. So what tools do we need to code this? You would need a Node.js, npm or yarn. Any of these would do. And the rest of the things, I'll be telling you the dependencies. So that's, and we'll be coding along. How does this get applied for real world applications? So when you write a decentralized application, as I was telling you, right, the user interacts. Could you type the tool in there? Okay, Node.js. And the second one is, that's all you need, an npm or yarn. Any of these two is required. Silvio, what's the practical use? I think every decentralized application that uses the graph, because you need to give the smart contract information to the front end of the decentralized application. How do you do that? That is via creating a subgraph for your smart contract, and at the end you get a GraphQL API which you can actually query to your front end and get all the pre-computed information. Would love to know best way to follow up with questions, best way to reach out. I'll be giving my Twitter link at the end. And we'll also be having a competition, right? I think there are less number of people today who have joined. However, we would be having this competition that if you are able to code along with me and post the code that I have written on your GitHub and tweet about it, then you'll definitely be getting something, maybe a PO-op or something. I'll let you know. But I would suggest everybody who is a part of this workshop to try to code along with me. It's a very, very simple subgraph, and it's my guarantee to take you along on this particular journey. All right. So the first thing we do, we go over here. Let me just close a few. So what we'll be doing is that we'll be coding a BAYC subgraph, right? For coding a BAYC subgraph, what everybody needs, or what we need specifically, is that what is the BAYC, when was it created, who was the owner, who is the current owner, what's the timestamp when it was created, just 3 or 4 of these information, very simple subgraph, right? And that's all that we'll be coding. For that, we would have to index the smart contract of BAYC. All right. So what we have to do is first go on the graphs hosted service. I'll be doing on the hosted service. You can also go and deploy it on the studio, which is the playground for the graph network. So if you want to create a decentralized subgraph, go on the graph network. If you want to create a centralized subgraph with the same code, go on the hosted service. Everybody is suggested to go on the graph network, but since we are in a hackathon, I'm doing it on the hosted service. Add a subgraph. Let's name it ETHMiami. Let's name it board ape. I think that works. This is for ETHMiami, not in prod. Okay, so let's just create this subgraph. All right, so the subgraph is the first interface is created. If you want to follow along, I'll have to give you the links. Sorry, guys. Let me just post it right here. This is the link. All right. Next. So this is the first dependency and the only dependency that you need from the graph side. I hope everybody has been able to come till here. So the first thing is just go ahead and deploy or download the graph dependency globally in your PC, right? This is npm install-g graph protocol graph CLI. So that like npm, right? If you like node version, you get the version and everything, right? Similarly, I would suggest everybody to download, can't see screen. I have actually not given you the screen. So just go ahead and download the screen, download this dependency, right? This might take some time, but if there are any questions, please let me know. Or if you're not able to download, please let me know. You need the latest node version also to actually work with this. So I hope everybody is able to download this graph protocol dependency. Once you have downloaded, you will be able to see like, graph-v. If I do this, you will be able to get a version over here, right? If you are able to download things, are you get, or where do I go? You have to go over here. Matthew, you have to go over here. Go on the graphs hosted service. Let me just do it again for you. Go on the graphs hosted service. Over here, I go on my dashboard. Here, add a subgraph. And here I name the subgraph, right? After naming the subgraph, I create the subgraph and I end at this particular page. How many of you have been able to reach till here? Raise of hands. Anybody? I would consider silence as yes, but Yash Jagtap raised his hand. Almost there. Okay, Christina. Nice. Everybody download the dependency. Make sure you do that. All right. So I have to move forward now. So if you have downloaded the dependency, you should be able to just say graph dash v, and you'll be able to, just now uh, I'm gonna create a folder. Let me just increase the size so everybody is able to see. So I'm gonna create a folder where, for example, if you are doing a node project, you do npm init, right? Similarly, I'll be doing graph init. So let's create a fresh folder, name it ETHMiami, right? There I go inside Miami, and there I do graph in it dash dash from contract. I need, okay, wait, right. What we need is that we need all the information from BAYC smart contract. How do we go to the BAYC smart contract? I go on OpenSea and I go on Board Ape Yacht Club. Here, there is this EtherScan link, right? This is the contract that I have to actually index. All right. So I go over here and I do graph in it dash dash from contract. So the contract and dash index events. This is all that I have to do. All right. Anybody facing any issues still here, let me know. I'm going very, very slow, so everybody can follow along. But if you cannot, this will also be recorded. All right. Ethereum hosted service. Let's name it. Name would be copied from here. I go over here. This is the name that I have to copy. That has my GitHub name as well as the other name, which is I have created of the subgraph. Board apes. So smart contract is the ABI. Let's name our contract as contract. Okay, subgraph is being initialized. So I've seen that sometimes there is some issue with the yarn that our product team is actually solving right now. So until then, what we can go do is actually go ahead and just open this demo cd ETHMiami. Right. So if you see, I'm able to reach this place, right? And this is done because of the command that I put in over here, right? Don't get confused. This is the command that I put in, right? Which is all the things over here. If you want, I'm gonna paste this in your chat. Sorry, Matthew. Yeah, I think we have a constraint of time. So I'm a little, yeah. Sorry, Ritu, but yeah, I think the E team will be giving you the recording. However, if you are not that late, I think all you have to do is go on the graphs hosted service, create your first subgraph. I'm gonna give a quick recap. Create your first subgraph, my dashboard, add subgraph, just give out all the names. You will be able to reach over here, this particular page, and here just just install all these dependencies. Once you install all these dependencies, then you have to go on for a fresh folder, go inside that particular folder and paste this command. Why? Because we are actually indexing this particular smart contract, which is the smart contract of Ether of Bored Ape Yacht Club. All right. I found it from this EtherScan page. I go here and this is the smart contract. All right. I hope I've been able to give a fair summary. If some people have been able to come till here, then the first thing that I do is see after graph init, I get this initial folder, right? I just open the terminal over here and do npm install so that all the dependencies are actually installed without issue. right? While the dependencies are being installed, there are four things that we discussed that are a part of the subgraph. First is the YAML file, which contains all the information that, you can say that contains all that is required to introduce your subgraph. That is the subgraph, the smart contract address, then all the entities that you will be creating in the schema file, and then all the events that you'll be handling by this particular subgraph. All right. So this is the first thing. Once this is done, the second thing that you guys have to do is go on the schema and let's define the schema. What do we want from the Bored Ape Yacht Club or Bored Apes? What do you want to create a subgraph for? Why do you want to create a subgraph for? As I told you, we want to list all the, we actually want to list all the Bored Ape Yacht Clubs that exist. Who was the owner? When was he the owner? And who created the subgraph? And at what time did he create the subgraph? And what is the ID? For example, this particular Bored Ape, right? It has a particular ID assigned to it, right? And it has an owner right now. If you see, there is an owner that you can find. This guy is the owner, right? In the who created it will also be there when you go in the beginning. So we have to create a subgraph which actually mentions all those things, right? So just keeping that in mind, we'll be creating our schema. So the first thing will be, we'll be creating a ape schema, right? Uh, wait, let me just reuse this code. Ape schema, then it will be an entity. Every entity should have an ID. Make sure you add that. Second will be ape ID, which is this ID, this particular ID, right? So ape ID. The second thing is I want to have a content URI. This should be, ape ID should be big int. Contract URI should be a string. Just remove this. Then we need a created at timestamp, right? And this will be a big int. This is the second. Oh wait, this is the second thing. Like when was it created, right? Then we want to know the creator of this app, this particular NFT. So that will be a user. We'll have to define the user in another entity, which will be a derived thing. Don't worry about it. I'll be explaining. And the last thing is, who is the current owner of this NFT? User. All right. So first we have defined the ape, and in that ape we have defined that we want the content URI. The content URI is this image. How do you get that image? That's the content URI. When was it created? Who is the creator? Who is the owner? Right? And that has to be a user. So we have to define a user now. User entity ID. This is ID. Then we have a ape. Okay, sorry. The ID. And the second thing is that we have to define the creator, right? This is going to be a derived field. What is a derived field? This is a one-to-many relationship. What that means is that one user can have many apes, but one ape can only have one user. So this is a one-to-many relationship, right? In which apes are many and user is one. And that's why it's a derived entity. If you want, you can go on the docs and read more about it. But I have some time constraints, so I have to move derived from. This contains the field, and here we mention, right? So this one is gonna be owner, right? Then there is gonna be a created. This is gonna be a ape again because it's a derived entity from this ape, and derived from, wait, derived from field, and this is the creator field where I'm actually deriving it from. So this is our schema and it's created. Now we will be changing the YAML file. We want the user information, which has, like, who, if this is the user, what's the ape he owns and who created it. And if this is the ape, right, this is his ID and this is his ape ID number, what's his information like content URI. From the content URI, you get the image, right? That's the first thing. Then the when was it created, the creator name and the owner name. For example, if you go on OpenSea, you can find this owner name. How are they getting it? Via creating a subgraph for the particular smart contract and actually getting a subgraph API, which is the GraphQL API, and querying it. So this is the same thing that we'll be doing by creating our own subgraph. These are the two things we have created. Now we'll be changing the subgraph YAML according to this. So this is the smart contract that we want to actually index, right? If you go over here, right, this is the smart contract, Port API Arts Club smart contract that we want to index. So the first thing. The second thing is, wait. The second thing is that we have to create an entity. Define, just write all the entities that we created here. First is the ape. So we define that ape. And the second one is user that we find over here, that we are going to define over here. User. All right. That's it. Okay, now just for simplicity, I'm just gonna index one event and handle that in the mapping file so that we actually only have 20 minutes left. So I'm just gonna create and do stuff with one event, not do it with handle, and we're just gonna take care of the transfer event. By the way, this event exists in the smart contract, and that's what actually we are indexing. If I go on the smart contract code, this is a BAYC. And if I just click event transfer, so this is the event, right? And this is how it is defined. Same as where we define over here. Address, index, UINT 256, same as it is defined over here, right? Address, UINT 256, right? So I've not done anything different. I'm actually just catering to this particular transfer event, and just will be creating my logic according to this. All right, so now we get into the main part, which is the mapping file that we have to write. So this is, as I was telling you in the slides as well, right? This is the logic. So from the graph node, with the using the YAML file, you get the transfer event and you get the data in the most rawest form. How do you convert it into this beautiful looking schema and you are able to query it via the GraphQL endpoint? That's why the mapping.ts file. Any questions up till here before I code the logic, which is the mapping.ts file? Hey Pranav, accept. Okay, I'll accept your LinkedIn. Don't worry. I'll be giving my Twitter at the end as well. So yeah. Anybody else? Any questions? Yeah. I can understand. This might be new for you, but I'm trying to make it as slow as possible for anybody who can follow along and code with me. Okay, I think I can move forward. I'm gonna code a mapping.ts file. This is a little challenging, but if you are with me, don't worry. Let's just be excited to do it. Graph, PH code gen. So using this, we get a generated file from which we'll be actually creating the mapping file. We don't need this. The first thing we need is the transfer event as transfer as what we need it as. We need it as transfer event. We don't need all these because we have deleted these particular events. And the second thing, this is, by the way, I'm taking from the contract.ts that's generated using graph code gen. All right, transfer. And the second thing that I'll be taking is the smart contract itself. Contract as contract. By the way, if you go contract, oh wait, comma. By the way, if you go in this generated file, transfer, I just type transfer, I'll be able to find the transfer event, which I can export, right? So I'm not doing anything new. And the second thing is the contract, this smart contract and the ABI, right? Which I can see over here, contract.json, right? That particular ABI is also something that I can export in my mapping.ts file for getting all the raw information from the transfer event, right? We don't need this. Oh, instead, what we need is this. There is one more thing, right, which is generated, which is the schemas. From the schema that we defined, I get a schema.ts, which I have to import because I have to use it, right? So I go inside the mapping.ts file and I defined the schemas, the first thing and the user. These were the two schemas that I defined over here, ape and the user, right? So I just get them in the over here. Let's just delete all the things that we don't need because we are only gonna index. We're gonna only look at one event, which is the transfer event. This is gonna be transfer event, right? Let's get started. Split screen. Oh yeah, Matthew, I can understand. No problem. So the first thing is let ape is equals to new. No. The first thing is let's just see if the ape is already taken up, right? So ape dot from here ape dot load params dot no param dot sorry event dot param dot param dot token ID. If it already, oh, this is a string, so I'm going to convert it to string. If it exists, then well and good. If it does not exist, if no ape, then I'm gonna just code it, right? So the first thing that I need to do is the ape is equals to new ape. This is a new object that I'm defining, which is gonna have the same thing as this, the ID, right? This is the first thing. Then ape dot creator, where I'm just taking this from, ape dot creator. It is from this creator. All right, nothing new. Okay, so far so good. Is equals to event dot params dot two hex string. By the way, how do I find this place thing? If I go on the generated file over here, and I just do transfer event, see over here down there. Yeah, here I can find out everything related to transfer event. Wait, let me try to give you the exact one that I'm looking at. This one, right? This has the to, this has the from, this has the token ID. So event dot param, right? And then the from, the to, and the token ID. That's what I'm taking over here. I hope that's not too confusing for you guys. So event dot from dot event dot params dot to. This is the second thing. After that, what I want to define, that's the created at timestamp. All right. Ape dot created at timestamp is equals to event dot block dot timestamp. I take it from here. Let contract is equals to contract dot, because I want the URI, the token URI, I have to take it from the smart contract, because this Bored Ape Yacht Club token URI is stored inside the smart contract. So I'm using the contract that I'm getting from here, from the ABI for the that particular this information. known as
Enough,
content URI.
enough. Sorry for interrupting you. We have 10 minutes left. If you just be aware of the time.
Sure. Okay, I'm gonna speed things up. Event dot address. This is the second thing. Ape dot to. This was the. It was content URI, right? Ape dot content URI is equals to contract dot token URI event, and then event dot param dot token ID. All right. Then we have the ape dot owner is equals to event dot params dot to. This is also the owner, right? So owner has to be ape dot owner. Any problems? Okay, event dot params dot to x string. Wait. Okay, sorry. This is the to address that I also have to write. Correct. And then I have to save the board API club that I created. Similarly, I have to do it for user, right? User dot, first of all, I have to just check if the user exists. So it's gonna be let user is equals to user dot load event. I'm gonna rush a bit, but I hope you are understanding. Dot params dot token ID dot to string. This is this user. And if we don't have a user, that then I'm gonna user is equals to new user event dot params dot to hex string user dot save as that I've done with that. Okay, so we have been able to code our mapping file, right? I hope you understood most of it. It is coming and derived from the generated file. So always go ahead and do code graph code gen. Once you have done that, I'm going to do graph build, check if there was any syntax errors. If there are no, then I'm just going to follow what's written over here. Oh, wait, I should also include a start block. Map YAML file, network, start block. Where do I find the start block? I go on this particular page. Here, the first transaction when it was created. And in that transaction, this is the block. Okay, I again do graph code gen and graph build. And that works. So I go over here, authenticate. By the way, you can also do this. I'm going to do graph auth. Right. And then graph deploy. That's it. And my subgraph is deployed. Awesome. So I have my subgraph deployed. No, wait. Yeah, this was the subgraph. And yeah, you can see that the subgraph is deployed and it has all the entities that we mentioned, right? The two entities, the ape and the user. These were the two entities, right? So if you want to know the first 5 apes and their token IDs, I can just go and query this. And this is the API key that I'm given. So you can go here, go to Atlassian or have your own GraphQL, Flask server or something created, and you are able to query the information. For example, what were the first 5 API, the first 5 apes that were created, what were their timestamp, what were their ID, so on and so forth. This is not 100% synced, and that's why this is taking time. But I hope you're able to understand. So the ape and the user information, whatever I want, I can go ahead and just, do things with it. Let's not do things with users. Oh no, I want to not do things with users and apes. I just want to query them and I get the information. So I hope you're able to learn the basics of how do you code a subgraph. And at the end, you get this nice looking subgraph, right? That's how you create a subgraph. If at all you were able to create a subgraph, or you got to understand a little bit about the subgraph, then I would really be happy if you could go and you can go on my Twitter and ask me about it, and also tag me and tag the graph protocol and tell that this was the first subgraph that I created. And I'll give you a pop for sure that you were able to create a subgraph in one go, which is also a good proof of knowledge that you have, right? So just tag me, and if you have any questions, you can always DM me on Twitter. My DMs are always open. I hope, given the time I had, I was able to do justice to your time, as well as you were able to code along with me. So this is how you index your smart contract to get whatever information that you want and portray it to your dApp's front end. Thank you.
Pranav, thanks a lot for your presentation.